Hi everyone, this is Dheeraj here from College SVCE wearing USN 1V20CS039. Today we have topics to discuss on solar photovoltaic system. Let's discuss on the topic. Photovoltaic system. A photovoltaic system, also known as photovoltaic power system, solar PV system or casually solar array, is a powerful system designed to supply usable solar power by means of photovoltaic system. Let me take the pen first. Now, PV is a method of converting solar energy into direct current electricity using semiconducting materials that exhibit the photovoltaic effect. A photovoltaic system employs solar panels composed of a number of solar cells to supply usable solar power. Power generation from solar PV has long been seen as a clean, sustainable energy technology which draws upon the planet's most plentiful and widely distributed renewable energy source, the sun. And this is the photovoltaic systems diagram, which is consists of cell, module, array, the solar PV array. This is the solar PV array. This is the sun over here. Now this is the solar PV array is directly connected to the DC voltage input and getting connected with AC voltage output. This is the sun tie inverter, and from this the main utility breaker panel is connected to AC utility meter, which is then connected to the solar power AC to grid. This is the components: uh, solar array, cabling, mounting system, solar trackers, solar inverters, charge control, and battery. Tracking. Now, what means like tracking? We'll discuss it. Fixed or tracking array. The PV array may either be fixed, sun tracking with one axis of rotation, or sun tracking with two axes of rotation. The default value is the fixed PV array. PV array tilt angle 0 to 90 degree. For a fixed PV array, the tilt angle is the angle from horizontal of the inclination of the PV array, that is 0 degree equals to horizontal and 90 degree is equal to vertical. For a sun tracking PV array with one axis of rotation, the tilt angle is the angle from horizontal of the inclination of the tracker axis. The tilt angle is not applicable for the sun tracking PV arrays with two axes of the rotation. The default value is the tilt angle equal to the station's latitude. This normally maximizes annual energy production. Increasing the tilt angle favors energy production in the winter, while decreasing the tilt angle favor energy production in the summer. This is now next slide contains PV technology classification. We have two technologies mainly thin film technology, silicon film technology, which consists of monocrystalline and polycrystalline. Thin film technology. What is this? Now let us discuss it. Silicon deposited in a continuous on a base material such as glass, metal, or polymers. The efficiency ranges from 5% to the 30%. The thin film crystalline solar cell consists of layers about 10 um thick compared with 200 to 30 layers for crystalline silicon cells. Pros: this is the lower cost substrate and the fabrication process. CUN is not very stable. The next slide contains silicon crystalline technology. Currently makes up 86% of PV market. Very stable with module efficiency 10% to 60%. 60%. Monocrystalline PV cells. Monocrystalline SI cells conversion efficiency for the type of cells ranges from, that is, 13 to 17% and can generally be said to be in wide commercial use. In a good light condition, it is the most efficient photovoltaic cell. Polar crystalline PV cells. The production of these cells is economically for efficient compared to monocrystalline. The efficiency ranges from 10 to 14%. The next slide contains working of the solar cell. PV cells are made up of at least two semiconductor layers. One layer containing a positive charge and the other layer contains a negative charge respectively. Sunlight consists of a little particles of solar energy called photons. This is the photons. As a PV cell is exposed to the sunlight, many of the photons are reflected, pass right through or absorbed by the solar cell. When enough photons are absorbed by the negative layer of the photovoltaic cell, electrons are freed from the negative semiconductors material due to the manufacturing process of the positive layer. These freed electrons naturally migrate to the positive layer, creating a voltage differential similar to the household battery. When the two layers are connected to an external load, the electrons flow through the circuit, creating the electricity. Each individual solar energy cell produces only 1.2 watts. Only 1.2 watts. To increase power outputs, cells are combined in a weather-tight package called a solar module. This module from 1 to several thousands are then wired up in serial or parallel with one another into what's called a solar array to create the desired voltage and apparent output required by the given project. Now let me rub the underlined sentences. Okay, this is the construction of the solar cell. Actually, this is the layer where the sunlight is directly coming to the surface, which is made up of metal contact and the glass, and the next layer is N type where silicon is present. Next, and after that P type layer, and then in N type there is electrons, and in P type there is the holes. Uh, all the all the solar cells components are listed here: glass, metal contact, PN junctions, P type semiconductor, N type semiconductor. Next, move to the slide. This is the working. In p-type semiconductor, holes are majority carriers and electrons are the minority carriers. P-type semiconductors are created by doping an intrinsic semiconductor with acceptor impurities, or doping an n-type semiconductor. A common p-type dopant for silicon is boron. N-type semiconductors have a larger electron concentration than hole concentration. The phrase N-type comes from the negative charge of the electron. In a type semiconductors, electrons are the majority carriers and the holes are the minority carriers. A common dopant for N-type silicon is phosphorus. This is here, phosphorus. Next slide contains applications at the rate PV. Commercial lighting. PV powered lighting systems are reliable and low cost alternatives. Security area and the outdoor lighting are all viable applications for PV. Consumer electronics, solar powered watches, calculators, and cameras are all everyday applications for the PV technologies. Telecommunications and etc. Next, move to the transport and installation cost. The cost of transport and installation are particularly high in remote and mountain areas. However, organizations which work in such areas are aware of this cost, but they are attracted by the modular nature of PV generators, which can be transported easily. And the next slide contains government support. The Ministry of the New and the Renewable Energy provide 30% subsidy. Yeah, 30, this is 30% of 30% subsidy to the installation cost of a solar photovoltaic power plant. 51 solar radiation resource assessment stations have been installed across India by the MNRE to monitor the ability of the solar energy. The GUI has also encouraged private solar companies by reducing customs duty on solar panels by 5% and expanding excise duty on solar photovoltaic panels. And here our topics comes to an end, and thank you very much.